Hello everyone. In today's video, we are going to solve typical past paper questions based on constant velocity problem. Let's get started. Find the vector which has magnitude 39 and is in the same direction as 12i minus 5j. This is written in the column vector form. So we need to find out the vector. Suppose that vector is vector A, which we have to figure it out, whose magnitude is given to you 39. Now this vector is the same direction as the vector B, which has the direction vector as 12i minus 5j. So this vector is related with the unit vector. So as we know that unit vector is equal to vector A divided by the magnitude of the vector. So from here we will find out the vector A. So vector A, we need to cross multiply this on left hand side. So the vector A will be written as magnitude of vector A and the unit vector. Now we need to figure it out, the unit vector. As we know that the unit vector of this vector will be the same as the unit vector of B. So if we figured it out, the unit vector of B vector, that will be the same as the vector A because they are in the same direction. So the unit vector of vector B is vector B divided by magnitude of vector B. So if I solve it here, that will be written as 12i minus 5j is the vector over its magnitude. Its magnitude is 12 square plus minus 5 the whole square. If I solve it, that will be 12i minus 5j divided by root of 144 plus 25. So that will be written as 12i minus 5j over root of 169. So 12i minus 5j over 13. This is the unit vector of vector B, which will be the same as the vector A. Now what we are going to do, we are going to substitute the unit vector value here. So the vector A will be given by the magnitude of the vector, which is 39, and the unit vector. Unit vector is 12i minus 5j over 13. So 13 will got cancelled from here and it will be 3. So if I multiply that, my answer will be 36i minus 15j. That will be your answer for the vector A. So we are going to apply the same concept in solving other past paper questions. So let's see one more example. A particle P is moving with a velocity of 20 meter per second in the same direction as 3i plus 4j. Find the velocity vector of P. As we know that we have to find out the vector A, and which is in the same direction as the vector B, whose direction vector is 3 and 4. So we will apply the same concept. Unit vector is equal to vector A over modulus of vector A. So the vector A will be written as magnitude of vector A multiplied by the unit vector. So unit vector will be the same as the vector B. So unit vector of vector B is vector B over the magnitude of the vector B. So if I solve it here, that will be written as vector B. So the vector B is 3i plus 4j divided by root of magnitude. Magnitude is 3 square plus 4 square, which will be written as 3i plus 4j divided by root of 9 plus 16, which will be equal to 3i plus 4j over root of 25. So that will be equal to 3i plus 4j over 5. Now what we are going to do, we are going to substitute this value of unit vector in vector A. So the vector A will be written as magnitude of A. Magnitude of A will be 20 and then the unit vector. That will be 3i plus 4j over 5. Now 5 will got cancelled with 20 and it will be 4 here. So the vector A will be written as 4 times of 3i plus 4j. So if I multiply that, my answer will be 12i plus 16j, which will be written as 12, 16 in the column vector form. That will be your answer for the velocity vector of P. Now at time t is equal to 0 second, P has position vector 1, 2 relative to a fixed point O. Write down the position vector of P after t seconds. So the position vector of P will be written as the initial position plus the time multiplied by the velocity vector. So the initial vector is given to us as 1 and 2, and the velocity vector will be considered as 12, 16, which we figured it out earlier. So let's substitute the value here. So the initial vector is 1, 2 plus the time t, and the velocity vector will be 12, 16. So if I solve it, that will be written as 1, 2 plus 12t and 16t. If I add it, that will be equal to 1 plus 12t, 2 plus 16t. That will be your answer for the position vector of P after t seconds. Now, a particle Q has position vector 17, 18 relative to O at time t is equal to 0 second and has a velocity vector 8, 12 meter per second. Given that P and Q collide, find the value of t when they collide and the position vector of the point of the collision. So the position vector of the Q after t seconds will be given by A plus t velocity vector v. So initial position A is 17, 18 and the velocity vector is given to us 8, 12. Let's substitute the value here. So that will be written as 17, 18 plus t times velocity vector is 8, 12. So if I solve it, that will be written as 17 plus 8t and that will be 18 plus 12t. Now, when they collide, we put them their velocity vectors equal to each other, and also we can compare the I vector and the j vector separately. If you solve it I and j vector separately, you will get the same answer. So right now I am doing it with only one of the vectors, with vector I. So I can compare the I vector separately and the j vector separately. Let's separate the I vector first. So 1 plus 12t will be equal to 17 plus 8t. Now move this 8t on left hand side. So that will be 1 plus 12t minus 8t is equal to 17. Now move this 1 on right hand side. That will be 12t minus 8t will be given by 4t, that is equals to 17 minus 1. So 4t is equal to 16. So t value will be given by 16 over 4. So it will got cancelled and it will be 4. So the value for t will come up 4 seconds. So that means they will collide after 4 seconds. Now we have to find out the position vector of the point of collision. Now if we substitute this value in the position vector of P or Q, we will get our answer. So let's substitute in position vector of P. So if I substitute the value 1 plus 12 multiplied by 4 and that will be 2 plus 16 multiplied by 4. If I solve it, my answer will be 49. 16 multiplied by 4 plus 2 will give you 66. That is the position vector of the point of collision. Let's see one more example. In this question, all distances are in kilometer. A ship P sails from a point A which has position vector 0, 0 with the speed of 52 km per hour in the direction of minus 5i plus 12j. Find the velocity vector of the ship. Now we have the velocity, we have to figure it out. This will be in the same direction as the vector b minus 5, 12. So we will apply the same rule here. So the unit vector will be given by the vector over its magnitude. So the vector will be written as, if I do the cross multiplication here, it will be written as magnitude of vector v and the unit vector. Unit vector will be the same as the unit vector of vector b. So the unit vector will be given by the vector b over magnitude of vector b. So that will be written as b minus 5i plus 12j divided by root of minus 5 the whole square plus 12 the whole square. That will be written as minus 5i plus 12j over root of 25 plus 144. That will be equal to minus 5i plus 12j over root of 169. So minus 5i plus 12j over 13. Now I'll substitute this, the value of unit vector here in the velocity. So my velocity vector will be given by magnitude of v, which is 52, and then the unit vector. Unit vector is minus 5i plus 12j over 13. Now 13 will be cancelled with 52 as 4. So that will be written as 4 times minus 5i plus 12j. So if you multiply that, that will be minus 20i plus 48j, which can be written as a column vector minus 20, 48. Now write down the position vector of P at a time t hours after leaving A. So the position vector of P after t hours will be given by the initial position plus the time multiplied by the velocity vector. Velocity vector will be minus 20, 48, and the initial vector is given by 0, 0. Let's substitute the value. So that will be equal to initial vector is 0, 0 plus t times the velocity vector. Velocity vector is minus 20, 48. So if you add it, that will be written as 0, 0 plus minus 20t, and that will be 48t, which will be equal to 0 minus 20t, 0 plus 48t, which will be given by minus 20t and 48t. That will be your answer for the position vector of P after t hours. Now, at the same time, the ship P sails from A, a ship Q sails from a point B, which has the position vector 12, 8 with the velocity vector minus 25 I plus 45j kilometer per hour. Write down the position vector of Q at the time t hours after leaving B. So the position vector of Q after t hours will be given by the initial position plus the time multiplied by the velocity vector. Let's substitute the value. Initial position is given by 12, 8 plus time multiplied by the velocity vector. Velocity vector is given by minus 25, 45. So if I add it, it will be 12, 8 plus minus 25t and 45t, which will be equal to 12 minus 25t and 8 plus 45t. This will be the position vector of Q after t hours. Now, using your answers to part B and C, find the displacement vector PQ at time t hours. So the displacement PQ will be given by, if I write down in the position vector form, will be written as OQ minus OP. So the position vector of Q minus position vector of P. Position vector of Q is given by 12 minus 25t plus 8 plus 45t, minus position vector of P will be minus 20t and 48t. Now I need to solve this. So that will be written as 12 minus 25t minus of minus 20t, that will be 8 plus 45t minus of 48t. So that will be equal to 12 minus 25t plus of 20t, that will be 8 plus 45t minus 48t is minus 3t. Here minus 25t plus 20t is minus 5t. So that will be 12 minus 5t and 8 minus 3t. That will be the displacement vector PQ at time t hours. Hence, show that PQ is equal to root of 34t square minus 168t plus 208. So I need to find out the magnitude of the vector PQ. So the magnitude of the vector PQ will be written as root of 12 minus 5t the whole square plus 8 minus 3t the whole square. Now I need to solve that. So this will be opened as a minus b the whole square. So if I write down, that will be 12 square minus 2 times of 12 times 5t plus 5t the whole square. This is again a minus b the whole square formula. This is 8 square minus of 2 times of 8 times 3t plus 3t the whole square. So that will be written as 144 minus 120t plus 25t square plus 64 minus 48t plus 9t square. Now if I add 25t square plus 9t square, which will be written as 34t square. Now if I add minus 120t and minus 48t will be minus 168t. If you add 144 plus 64 which will be given by 208. So our displacement PQ will be given by root of 34t square minus 168t plus 208. That is proved. Now find the value of t when P and Q are first 2 kilometers apart. So this is given you the distance. We just figured it out. The distance PQ is this equation. So that means this equation is equal to 2 kilometers. So as you can see that I have substituted 2 is equal to root of 34t square minus 168t plus 208. Now I need to eliminate root. So I will take the square on both the sides. So let's take the square on both the sides. So that will be written as 4 is equal to 34t square minus 168t plus 208. Take this 4 on right hand side. That will be written as 34t square minus 168t plus 208 minus 4 is equal to 0. So 34t square minus 168t plus 204 which will be equal to 0. Now I need to apply the formula to solve this quadratic equation. As you know that the formula to solve the quadratic equation is t is equal to minus b plus minus root of b square minus 4ac over 2a. Now what are the values of a, b and c? The value of a is 34, the value of b is minus 168 and the value of c is 204. Why? Because if I compare this with the general form of a quadratic equation which will be written as ax square plus bx plus c is equal to 0 form, then we can compare the coefficients of a, b and c which are this. Now I will substitute the values here. That is minus of minus 168 plus minus root of b square 168 the whole square minus 4 times a is 34 times of 204 divided by 2a. 2a is 34. So that will be written as 168 plus minus root of, if you solve this, your value will be 480 divided by 68. It's equal to 168 plus root of 480 over 68. My second answer will be 168 minus root of 480 over 68. Now if you solve this, your answer will be equal to 2.79. If you solve the second one, your answer will be 2.148, which will be approximately written as 2.15. Now they ask when they first 2 kilometers apart from each other, the answer will be given by 2.15. Let's see one more example. A particle P is initially at the point with position vector 30i plus 10j and moves with a constant speed of 10 meter per second in the same direction as minus 4i plus 3j. Find the position vector of P after t seconds. So we need to find out the vector which is in the same direction as the vector B. So I will apply the same formula. Unit vector is equal to vector A over magnitude of vector A. So the vector A will be written as, do the cross multiplication on left hand side, it will be magnitude of A and unit vector. Magnitude of A is given to us as 10 meter per second. Only thing I need to find out the unit vector. So the unit vector of the vector B is vector B over magnitude of vector B. So let's solve it here. That will be written as minus 4i plus 3j divided by root of magnitude. Magnitude is minus 4 the whole square plus 3 square, which will be written as minus 4i plus 3j over root of 16 plus 9. So that will be equal to minus 4i plus 3j over root of 25. So the vector will be written as minus 4i plus 3j over 5. That is the unit vector. Now I am going to substitute this value of unit vector here in vector A. So the vector A will be magnitude of A multiplied by the unit vector. Magnitude of A is 10 and the unit vector will be minus 4i plus 3j divided by 5. Now 5 will got cancelled with 10 and it will be 2 here. So that will be written as 2 times of minus 4i plus 3j, which will be equal to minus 8i plus 6j. If I write it in the column vector form, this will be written as minus 8 and 6. So the position vector will be written by the initial position plus the time multiplied by the velocity vector. Velocity vector is minus 8 and 6. So the initial position is 30, 10 plus t times the velocity vector. Velocity vector is minus 8, 6. So if you multiply that, that will be equal to 30, 10 plus minus 8t and 6t. So if I add it, it will be 30 minus 8t and it will be 10 plus 6t. That will be your answer for the position vector after t hours. Now, as P starts moving, a particle Q starts to move such that its position vector after t second is given by minus 80, 90 plus t times 5, 12. So this is the initial position he has and this is the velocity vector. Write down the speed of Q. As you know that the speed is given by the magnitude of the velocity. So the velocity is 5, 12. So if I take the magnitude of 5i plus 12j, that will be written as root of 5 square plus 12 square, which will be equal to 25 plus 144, which will be equal to 169. So my speed is given by 13 km per hour. Now find the exact distance between P and Q when t is equal to 10, giving your answer in its simplest surd form. Now the distance PQ, if I write down in the form of a position vector form, will be written as OQ minus OP. The position vector of Q minus position vector of P. So the position vector of Q will be written as minus 80 plus 5t, 90 plus 12t, minus position vector of P will be written as 30 minus 80, 10 plus 60. Now as they give us that we have to find out when time is equal to 10. So I'll substitute the value of 10 here in place of t so that my calculations will be easier. So let's substitute the value here. That will be minus 80 plus 5 times 10. That will be 90 plus 12 times 10 minus of 30 minus 8 times 10. That will be 10 plus 6 times 10. So if I solve it, that will be minus 80 plus 50. That will be 90 plus 120 minus of 30 minus 80 and that will be 10 plus 60. So that will be written as minus 30, 210 minus of minus 50 and that will be 70. So if I add it, that will be written as minus 30 minus of minus 50 is plus 50. That will be 210 minus 70. So if I solve it, that will be 20 and 140. That will be a distance PQ. Now I need to find out the magnitude of PQ. So the magnitude of PQ will be written as 20I plus 140J. So that will be equal to 20 square plus 140 the whole square. That will be written as 400 plus 19600. So if I add it, that will be equal to 20,000. So from this double zeros you are taking the root, so your answer will be 100 root 2. Thank you so much for watching. I hope you enjoyed my video. Don't forget to like, subscribe and leave a comment down below. Bye bye everyone.